Hi guys, Buildzoid here, and today I'm gonna kind of probably, I just wanted to do this video, basically pointing out how this motherboard, considering the price point, it's really not cost effective in terms of how it's designed. So we're just gonna, I'm just gonna go over this motherboard and point out all the things I would just straight up basically remove or replace with cheaper alternatives, or at least what should be cheaper alternatives, because I do actually have the problem, like, I don't know the bill of, like, I don't have a bill of materials for this board, so I don't know how much it actually, like, every single part of this board costs as rock. But considering that some of the other board vendors have motherboards that are just straight up better, in my opinion, and it's pretty, I'd say, I have a good guess of where the priorities went wrong. So then, let's start off with the most obvious thing. I don't think I need to justify myself saying that this is pointless. Right? This literally doesn't do anything. This makes the board look better. It doesn't do a damn thing for the actual quality of the board, right? If we talk about like VRM cooling or performance metrics of this motherboard, this does nothing. Absolutely nothing. So it's like one of those things where when you're down costing a motherboard, would you rather like remove all the useful things like the VRM, the postcode, the dual BIOS, the useful features? Would you rather they remove all of those, or would you rather that they drop all of the artsy heat sinks, the I/O covers, the M.2 heat block? Because this is another thing. It's like I don't think this costs too much, but this doesn't do anything. Like, there's no fins on this. If anything, this probably makes your M.2 SSD run hotter because it's just another barrier between the surface of the M.2 SSD and the air that's ultimately going to be cooling it. And this doesn't add any surface area, right? So, yeah, this is also pointless. Next, we have these VRM heatsinks, which just like, yeah, they have some fins, but as far as being a VRM heatsink goes, I'm pretty sure you could design something cheaper and much, much more effective if you weren't so hung up about having the heatsink look good, right? Like this overhang, for example, right? Yeah, it adds surface area. It's just unfortunate that that surface area is really, really far away from the actual heat source, so much less effective than it could be. Because in order for this surface area right here to do anything, the heat has to travel from the bottom of this freaking heatsink all the way through this, like, fin thing. I'm not going to call it a fin, well, it's kind of a fin stack, even if it's pretty pathetic, but it has to travel up that, then do like a curve into the actual overhang, and it's just like, which, like, the actual direction of travel, that doesn't matter. The problem is, that's a lot of distance to cover. If this overhang was connected to the bottom of the heatsink right here, it would be much more effective. Except for the part where that would probably restrict airflow, but that's why you don't make fancy, stupid heatsink designs like this. You just take a block of aluminum and you cut fins into it like that, which is also really, really cheap to produce because you can produce that with, extruded aluminum will do that for you. Like, you can just extrude aluminum to get that. So, and that's really, really cheap compared to, like, actually machining fins into something. So this is not cost effective. This is not a good heatsink, From a price versus cooling perspective, this is a disaster. It looks pretty though, so that's kind of that. Same for this heatsink. I mean, that's just a smaller version of the other one. So both of those are terrible heatsinks. Now we're going to get onto the actual sort of electrical design side of things, and we have a 4-pin here, which is completely pointless. And I've seen a bunch of people comment about how, oh, the 4-pin is useful when you have a 4-pin only power supply. Watch. Right? And the funny thing is, let me just get that out. Board's not mounted on anything, so there. And same thing. You can, if you have a PSU with only a 4-pin, you can plug it into the 8-pin. There's really no problem doing that. That connector is very much specifically designed to accommodate that kind of usage. And this is an 8-pin, well, 4+4-pin power connector off of a EVGA PSU. So, it's not like some special one or anything. So that 4-pin is pointless because that 8-pin over there can handle 480 watts at the very least. And this VRM definitely can't, and this CPU definitely won't pull that. This is a 2700X. This maxes out around 260 watts of power on the 8-pin itself. Like, that's how much power would go into the 8-pin, around 260 watts. So that 4-pin over there, completely bloody pointless. Now, on LN2, that 4-pin would actually be kind of useful. This motherboard is never ever going to get used on liquid nitrogen, so pointless. This is just making the motherboard more expensive without actually adding any functionality to it. Similar to the I/O cover, right? But it looks good on the marketing. I assume that the marketing department decided, like, oh, people who see the extra 4-pin are going to think that it makes the motherboard's power delivery section more powerful or whatever, and that's why it's there. Because from an engineering perspective, that is literally the most pointless connector on the entire motherboard. It doesn't do anything. Next, we have this extra choke in the memory VRM. Again, literally pointless. You don't need to, like... First of all, I don't have the bill of materials, so I don't know how much current that choke is capable of handling. But I have a sneaking suspicion either of these is able to handle 20 amps. At least. The funny thing is, your RAM is never going to pull 40, and that VRM before it is never going to supply 40. This is the, this is the equivalent of putting a transmission capable of handling 1,000 horsepower into a car that produces 100. Literally pointless. It doesn't, like, it's completely, utterly pointless. Or, it's not even like that. It's, well, no, that's probably the best analogy I can think of. Literally pointless. It doesn't do a damn thing. You have a similar situation going on with all of the inductors in the VCore VRM, because if we look at ASRock's marketing for these, thank you ASRock, you can see that they're marketed as having 45 amps current capability. The thing is, there's 8 of them, and with 8 45 amp inductors, that means this VRM has 360 amps of inductor on there, right? The thing is, this VRM is never going to push 360 amps, and this CPU is never going to pull 360 amps. Normally under Prime 95, a 2700X is going to pull at 1.4 volts. It's going to pull between sort of 140 and 150 amps. Basically, your VRM only needs like a 200 amps of inductor, not 360. In fact, you'd probably be okay if you removed half of these. It would still not overload any single inductor. And the other thing is, because they're putting these inductors in parallel, they actually cost more. Because in order to do this, you need to raise the inductance rating of each of your inductors. So there's 2 of them in parallel, so each of them is rated for 500 nanohenries. If you wanted to buy a 250 nanohenry 50 amp inductor, it's going to cost less than 2 of these. Like, I can guarantee it, that for the same amount of board, like, footprint, it's going to cost less. So this is stupid. This is pointless, and you could probably get away if you just removed half of them. And the other thing is, this board doesn't even have LLC. So under most loads, it's never going to exceed like 1.3 volts, 1.35 volts-ish. So yeah, pointless. Literally pointless. You don't need this whatsoever. I have no, like, it looks cool on marketing because it looks like an 8-phase, but from a practical perspective, this is a waste of money. It makes the board more expensive. It doesn't add any functionality. Again, same situation as the memory VRM over there. And the SoC VRM, I'd argue, has the same problem. You could just use 2 of these 45 amp inductors instead of 4 of whatever the hell these are. So, yeah, those can go. And finally, this board has 12,000 hours rated Nichicon capacitors. The thing is, if you bought 5,000 hour rated APAC capacitors, which ASRock uses on their cheaper boards, because initially I was thinking, oh, they're using these 12,000 hours rated ones because they use them everywhere. But that's not actually true. On B450 boards, they use a 5,000 hour rated capacitor. So it's not like they have a shortage of 5,000 hours rated capacitors. So this could have easily had 5,000 hours rated capacitors, which are significantly cheaper than these ones, and then they could have just made the VRM more efficient and run cooler, right? Because the thing is, these are 12,000 hours at 105 degrees, whereas the 5,000 hours rated capacitors are 5,000 hours at 105 degrees. So they're the same temperature, but one of them lasts about half as long. The thing is, if you ran that 5,000 hours rated capacitor at like 85 degrees instead of 105 degrees, it would last 3 or more than 3 times longer than its rated lifespan. You could easily see them lasting 15,000 hours or 30,000 or even 50,000 hours if you just ran them 20 degrees cooler or 10 or even 10 degrees cooler. Like, you really don't need to lower the temperature that much for the capacitor to last a lot longer. So using 12,000 hours rated capacitors instead of a better VRM with better cooling, marketing decision. Like, this is just, because the thing is, it does make for a nice marketing point, right? You can market that you have 12,000 hours rated capacitors. The thing is, if you actually run them hotter than everybody else is, then they're going to last a shorter period of time. Anyway, like, that's the thing. You can kind of go 2 ways with choosing your capacitors, right? You can either design something that runs so cold that basically even the crappiest Chinese electrolytic is never going to fail, or you can design something that runs incredibly hot, and then you need to spend ridiculous amounts of money on really high quality capacitors. I'm pretty, and that's ignoring the fact that running things cooler generally makes them last longer, period. So if you're designing something, your priority is probably make it run cooler, like at least it should be, if your goal is to get a long lifespan out of it. This is just like, the priorities are all wrong, and the thing is, the reason why we have this is because board vendors have a really hard time selling boards, right? And because the thing is, if you look at most, like, the problem, like, as far as I'm concerned, the problem is that most reviewers will give a 9 out of 10 to any motherboard that goes across their desk. The end result is that marketing departments have run out of ideas. Incidentally, the whole reason why we have fake phases in VRMs is because marketing departments basically came up, like, a few years ago, they figured out, oh wait, more phases is more better. And they explained that to all the reviewers, which is true. If you have more real phases, it is actually better than less phases. But the problem is that phases are expensive because they add a ton of complexity as you basically add them, right? Making a real 8-phase VRM for vCore is ridiculously expensive because you're going to need not one controller, you're going to need 2. Because right now, the only voltage controller you can buy that does like 8 phases for an AM4 board is an IR35201, and it does 8 phases. So you'd need another controller for your SoC VRM at that point. And, well, that massively increases the manufacturing cost of the motherboard because instead of 1 controller chip, you have 2 controller chips. Then you need to have 8 drivers for your vCore. You need to have more drivers for your SoC. This thing only has 3 driver chips across it. Like, there's 2 drivers down here, and then you have another driver up there. Right? That's 3 driver chips. If you wanted to build a real 8-phase, you'd need 8 of those. Way more expensive. So, but anyway, the marketing departments at some point told everybody, like, more phases, more better. And then they told engineering, hey, we need to put more phases on a motherboard, on the $100 motherboard. And engineering went like, that's literally not possible. And they're like, just make it look like an 8-phase. This is the result. It looks like an 8-phase. It's a 4-phase. It's way more expensive than designing a good 4-phase. Well, it's probably more expensive than designing a good 4-phase. Depends on how you define a good 4-phase. If you went with something like the... if you wanted to, you could make some really, really expensive 4-phase VRMs. Like use 70 amp power stages, 70 amp inductors. At that point, you could argue, yeah, maybe you should have just gone for more phases with less powerful components, but nonetheless, the point still stands. This is dumb, right? Like, this is not cost effective. This just, yeah. Just the priorities are all wrong, because basically board vendors are more concerned about making a motherboard that looks like it's going to run well, more so than making a motherboard that actually runs well, because, proper heat sinks don't look very good. This is just kind of a fact. Like, look at all the motherboards from, like, just go back and look at what the VRM heatsink designs looked like. And if you go far back enough, you're going to find heatsinks which are, like, solid copper, tons of fins, heat pipes everywhere, like, and they look horrendous. Like, they really don't look good, but those are proper heatsinks, not this, Like, this is not a good heatsink, and I'd argue you can probably make a proper fin stack work. You know, if your designers are good enough, they should be able to figure out a way to make a functional heatsink, maybe not stylish, but at least acceptable looking, right? But then you have the things like the plastic I/O covers. Like, plastic I/O covers weren't a thing until, I think, X99 with the Rampage 5 Extreme. The Rampage 5 Extreme, I think, is like the first motherboard to have an I/O cover. And the reason, like, and there I don't have a problem with it because the Rampage 5 Extreme is a high-end motherboard, had a perfectly good VRM. It was really expensive. That I/O cover wasn't eating into the quality of the rest of the board because, like, if they wanted to add something to that board, they could have just made it even more expensive. That board was $500. They, you know, we added $20 worth of LEDs. Well, now the board's $520 instead of $500. Like, they wouldn't have had a problem doing that. But when you have a motherboard that costs $100 and you start tacking on useless crap like this, it eats into the quality of the board. And the thing is, the priorities are just, like, yeah, wrong as far as I'm concerned. Now, that's not to say that I can't see you know, like, a manufacturer could find a niche of making very pretty, completely worthless motherboards that are meant for running CPUs at stock, right? And you could make them on like a H series chipset, or for AMD, they have the non-overclocking chipset is like A320. So you can make an A320 board that looks really pretty and absolutely sucks in everything else, but hey, you can't overclock it. So at that point, you know, you're not gonna put much stress on the VRM, and you can fully focus on aesthetic design instead of this mishmash of whatever the hell this is supposed to be, because it's like it's halfway into everything. You know, it just kind of, yeah. So, and I just wanted to point that out because it's just like the boards could be less expensive. Like, the boards could either be less expensive without sacrificing quality, or they could just have more quality at the same price point. With a lot of the boards we have right now, because it's just they put too much stake in bling, right? Like, useless, pointless bling everywhere. So, yeah, and I just wanted to point that out. So that's it for the video. I chose this board here from ASRock specifically because it kind of does a little bit of everything. You know, you have your plastic I/O covers, there's some RGB on it, but the RGB, like, this doesn't really do that much RGB, which I honestly argue if your motherboard is just like a Christmas tree of RGB, I can get that. Like, I actually like the Gigabyte Christmas tree motherboard effect. Like, I appreciate it. But, you know, but at that point, I would stop worrying about marketing the motherboard for having a great VRM, because obviously your focus is for delivering the maximum amount of Christmas tree for the minimum amount of dollars. And, you know, if that's your priority, then make it your priority. Don't half-heartedly, you know, put 3 LEDs under the chipset heatsink and then ruin the rest of the motherboard because it needs to look good. Yeah. So just kind of wanted to point that out. And yeah, and like, ASRock makes good boards. I'm not picking on them. Like they make some good boards. They also make things like this. For example, like, as much as I hate the BIOS on the X299 OC formula, I can't really fault that board for being good, because it is. Like, it's capable, it's competent, it's even pretty good at, like, it's even damn good at memory overclocking. I just hate the bloody BIOS. Okay, that's never going to change. But that is a solid motherboard. And if you can survive the ASRock BIOS experience, then knock yourself out. But when you have a board like this, where it's like, and that board has really good build quality, but this doesn't have anything, in my opinion, which it has going for it, which is why, and it does, you know, it does the artsy heat sinks, it does the silly I/O cover, it does the million inductors that you don't need. Actually, like, the extra inductor in the memory VRM, this is unique to ASRock. Like, I've not seen any other board vendor bother with this. Like, Asus has some boards up in the higher end where they have, like, straight up 2-phase memory power, but when you go into the cheaper boards, everybody has a single-phase memory VRM with one choke, because they realize that putting the second one in there isn't doing a damn thing. And then there's ASRock, where it's like, more chokes, more better, put more chokes everywhere. I'm surprised they don't have 4 of them right here, you know, for input filtering, which, again, would be completely bloody pointless. But Yeah. Anyway, I'm making this video unnecessarily long at this point. So thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down below. And if you'd like to support what I do here with Actually Hardcore Overclocking, I have a Patreon, PayPal, t-shirts you can buy. You can find a link to all of that down in the description below. Those all help out immensely. And yeah, that's it for the video. So goodbye. Where's the mouse? There it is.